And then what I can do, I can write all over the page, and then you can't type on it, apparently, until I'm finished. I'm not in love with this Microsoft software, but I want to switch over to Linux eventually. Anyway, so it's moving in a uniform acceleration, but then they give its velocity in the positive x direction. So it has some v naught equals, I'm going to skip what the value is, but it's to the right. So it's v naught x, we can say. And at that time, its x-coordinate is this number here. So it has an x naught as well. Alright, so I've used both of those two things. Those are my initial conditions. And those are going to be part of the kinematic equation. Because you're starting in the basic kinematics, it's quite likely that the basic equation plus v naught t plus 1/2 a t squared is going to apply.
Sorry, you're doing completely different than I did.
I haven't even read the whole question. I'm just saying, I just instinctively think that's going to likely come up here. And I just isolated two of the things off of that.
Mm-hmm.
I know this one and this one already. That's what made me think of that.
Gotcha.
If its x-coordinate is 3.15 sometime later, so that's going to be x. And therefore, that's that part. Notice it's less. Oh, wait. Sorry, it's not x. X-coordinate sometime later. That's the time. So that's going to be the time. Is -5. Okay, that's going to be the x. So, but it has gone back to the left. So even though it's moving to the right, it ends up somewhere over here to the left in the end.
Mm-hmm.
Alright, so if we draw a number line for it, its initial position was about 3.24. Its final position is -5. But its initial velocity was this way. So somehow it's going to turn around.
Mm-hmm.
Which means the acceleration must be negative.
Yeah.
But what is the acceleration? But the fact is, I have everything on here. I have the final x, I have the initial x, I have the v naught, I have the time, I have everything but a.
Okay, I did this way too hard then. I made this way too difficult. I drew a graph, and I tried to take the area underneath the curve.
Yeah, she tried to bring in some calculus, which is where all this comes from. But if you integrate what's under the line, you get velocity, and integrate that, you get position. I think. Well,
The fact you get.
no, you're right. Yeah, if you integrated this velocity, your drawing is not quite to scale because this is -5 down here.
Mm-hmm.
Oh wait, centimeters per second. Oh, this is velocity versus time. You don't have any way of knowing that up front because you don't know a. The other equation, one I didn't mention, was v equals v naught.
Yeah, that's what I'm solving for, because area inside really excited.
Plus at. Yeah, but I don't need the final v. Oh, you wanted to do it that way instead. Yeah. I don't know the final v. That's the problem. If I look at this equation, the things I know are this one. I know the t. And I know the v naught. I don't have the final v. What's its velocity in the end?
Oh, goodness.
I only have its position.
Oh my gosh. I thought it was -5 centimeters a second, not -5 centimeters. Oh, okay. Well, I should have seen that then.
Yeah, a helpful way to catch those is to really focus on the units. So that's why some teachers really obsess about writing them down. that's not as important as
Yeah, and I did
saying
correctly though.
Yeah. As when you read it, because when I looked at that, this is when I first wrote this down. I did make a mistake here. I put X. I erased it. If you go through the video, you'll see that I put X here.
I saw you do that.
And then I looked back at it and said, wait a minute, that's seconds. No, that has to be time. And also, it was only, it didn't make a lot of sense to me why it went a little bit to the left. But then I saw that, and then I said, oh, -5, and look, it wraps around, no unit. I didn't say anything out loud, but I was definitely sensitive to that. Because I had already just made a mistake there. But I did double check it when I went to put the variable to the value. And that's more important than all the writing down of it.
Yeah.
Okay. So if that one got you, then you probably felt like you didn't know how to do the next one for the same reason.
Exactly. So I honestly didn't really cut this until about an hour or two ago, and I started some problems again and actually started getting the right answer. I'm like, well, so maybe I actually do know how to do this stuff.
Yeah, so that just messed with your confidence a little bit.
Well, we'll start number 3.
That is a huge thing in physics. By the time I hit physics, I was a really confident person. And so when I would make mistakes like I did just now, I just don't let it hit me.
I'm just thinking about the test and how perfectionist this professor is.
Oh, yeah.
He's already told me, hey, maybe you should take a lower level of physics. And, like, spent half the time I was there at his office, I was telling me that instead of helping me with the problems.
Oh. That's why there aren't a lot of physics tutors. Because we're all dicks. We all start out that way. That's not supposed to say that.
You think I can do it?
Yeah, okay. You can do this stuff. The math is not that hard. You gotta develop some more word problem techniques. Well, so the thing with the units I gave you was 1. This thing with the equations. Notice I wrote the equations down. You don't have the right equation anywhere on that page. The odds were like overwhelming. It was going to be one of these two.
Yeah, I started doing that on the next one, on 4, 5, and 6. But in this one, I did part of it and didn't do the rest of it. No, I didn't do any of it actually. Never mind, that was carried down. Yeah, but number 4, I swear, look, I started doing that with the equations, and I got that one right.
Yeah.
Well, actually, not all of it. There's a part of it at the end that I'm not getting right.
Good. Alright.
I'll ask about that in a second.
In order to, let's see, scroll down there. Clear that off. Okay. So let's you finish that one.
So number 3.
Okay.
The next one.
Driver crossing into the brakes. Thesis true document. Violation of making a straight skid marks. Yeah, this has got to be kinematics. I just have to decide which equation, how to map everything out. It's not a multi-phase problem. It's not a multi-dimensional problem. So it should be one equation.
Mm-hmm.
Go for it.
So, oops. I got all the way down to the bottom, and then my units weren't matching up, so.
Oh, man.
What happened?
I think it just logged you out. Piece of crap. Windows.
Alright, well, let's go again.
It's because I picked that up. And I touched in the wrong place.
Somehow close the window.
Randomly touch that X somehow. Oh, doesn't seem likely. The computer doesn't like for this is beautiful hardware. Oh yeah, I wasn't wanting to give it back to you.
That's the whole reason you took it away. Okay.
This is beautiful hardware, but the software is so bad.
Yeah. Oh god, no, it's right there.
So then it doesn't remember. That's why I did the incognito, so that your information would not be captured. Yeah, so that one, you can do that one just fine. I mean, which equation is it? I have acceleration, I have time, I have distance.
It's not the one I thought it was.
What speed does a car have when it strikes the tree?
What is that?
So I don't have any kind of velocity information at all.
I don't know what I did on it.
Maybe it's not. This is not quite that simple. Definitely have A and T. So you have change in velocity.
Okay. Did I write this down wrong? Is there ever a case where I cannot put in the V naught for that equation?
Only if it's 0.
Oh wait, I see what's up. No, that would still be valid.
Delta V is valid, yeah.
That's right. Okay. Alright, so you have acceleration, time, you have displacement.
So you have a delta X.
Exactly.
There's a form of those. I didn't quite show it on my summary.
I started using this one down here, bottom.
That one there?
Bottom.
Oh. No, it's not gonna. I don't think it's gonna work with that one because you don't have either velocity. And the difference of two velocities squared isn't quite gonna work.
They don't have the velocity?
You can get VF squared minus V naught squared from that. They want the final velocity, but they didn't give you
say that again. I thought we had velocity, but we don't.
Well, yeah. So let me get to it. Right. Yeah, so I have A, I have T, I have delta X.
Mm-hmm.
So the delta X makes me want to think of the delta X equation, which is just like the one I drew before. There's just no X naught on the right side. I do have V naught T on the right side plus 1/2 AT squared. So if
I couldn't solve for final velocity.
So the other choice, which is definitely attractive, is this one. And then there's only the one more equation, right? We know it's not that one.
Mm-hmm.
If I go through these, let's start with the one that made sense, and I thought of it too. I have that.
Right.
I have that. But that's it. I want VF. So I'm cool to have VF in the final equation. I do want it in there. But not all by itself. I have another thing in there, but I don't have. So that's just not going to work. So, I mean, if I don't really deeply understand the problem, which is...
I did get the change in velocity, though. So you can get the...
How did you get the change? Is A delta T? Yeah, you're right. You can get the change in velocity.
So then you get one of the velocities.
You can't get either of them. Well, you can get one once you have the other. Yeah. So once you get one, you can get the other. And you're correct. You're going to need that in the end.
That's what I did.
Oh, it's negative. Yeah, that's good. Okay, so that is a good first step, but it's a supportive step. It's going to back up. It's going to get you to the answer. So it's not really the first step. It's really like the second step. You can accept it as the first step. You can set it aside and say, I have that now. Now, if only I could get one of the two. But you still have to have one of the two. And you don't have either.
Well,
you have
plugged in.
You have the delta V, but you don't have the VF and you don't have the V naught. You don't have any. You only have now the ability to connect the two, which you need to solve this problem. You just don't need it yet.
You can still solve it.
But let's go back to the equations.
You can still solve for one.
Look at what I said that we had. I labeled these, and I intentionally write the variables down. When I teach people when they're first starting into this class, right at the top of the problem, write all the variables down, what they're equal to, and then the unit, so you don't make that unit mismatch. Because they're all new concepts to you, so it's easy to mismatch them. Alright, so I know AT and delta x. And as soon as I dump that into the pattern matcher in my head, it gave me this equation, because there's so much of that is in there. So I have delta x, I have A, I have T. Magically, that only leaves one thing. And it has to be that way. I mean, real physics problems, they're not like this, where they're just going to say, oh, one of the equations I gave you earlier is going to match with all the variables I just gave you. And they make them multi-step. So you're right, the V naught is not what you want. It's not what they asked for. But once you get that, of course, now you know how to make the step to the thing you do want.
I still think I did this. I think I did it in a way that would still solve for VF.
There are other ways, yeah. But
because what I did is just that
if you say that VF squared minus V naught squared equals, it doesn't equal delta V.
No, it equals V naught. That's why I substituted it. Right?
Oh, I mean, now that we have this one, solving this equation here is going to give you this one, which now makes this equation solvable.
So you're telling me V naught does not equal VF minus a negative 18.8 millimeters a second.
No, you've done something with the algebra there you can't do. These two are both squared. They can't. How did they get inside the square with something else?
That's what I'm saying. I solved for V naught basically and stuff that from that equation that you have there.
Oh, from the upper one?
This one you have right here?
Oh, that's not an equation. Oh, you're saying, yeah, you're right though.
I know it's not an equation, but yeah.
Yeah, but you're right though that delta V equals VF minus V naught.
And it's solved for V naught.
And so, but you still can't get it from here. I don't think. That lets you get rid of one of them. Oh, so you said that V naught was equal to delta V minus VF?
Yeah.
Yeah, you're right. That would produce a quadratic, and then you could solve that.
So why can't I get to work?
It would be a really hard way to do it, though.
I'm gonna get my
This equation here. Let me say, this is a convenience equation. It is not necessary. It's not really, in my mind, one of the kinematic equations. It's what you get when you combine the velocity and position equations.
Show me what you mean by that.
Well, I don't know how badly I want to go through it, but
okay, never mind.
Because it would be a little bit of a derivation. But what I mean to say is that there are three kinematic equations. So two. There's really just two. The velocity equals AT, and then the delta x one. The delta V and the delta x one. That's it. That's really all there is. The third one is a combination of those first two.
Yeah,
you go through a process. Oh, yeah.
You can't derive it very easily.
It isn't useful here, though, is the point.
Gotcha.
It's a tool. It's not really fundamental.
Well, can you show me what I did wrong with the units here? Because I got down the bottom here. I couldn't divide the units out correctly.
They say where you went wrong was right there, where you started putting numbers in, and you're doing a derivation. So I wouldn't have wanted to start sneaking any numbers in there.
Right, okay.
This would just be 2a delta x.
Okay.
Because those are givens. Beyond that, V naught, you made it VF minus delta V, which is A delta T, which you already had. Yeah. Oh, wait. No, did you do that okay? You squared this out. Yeah. No, that's right. That's going to be VF18, and then there's no factor of 2 there. And why does that go from 717 down to...
Oh, 717's down here.
Oh, that got carried around?
Yeah.
Where does the 353 come from? Oh, that's squaring that guy out. Oh, you just FOILed it out.
Yeah.
No, it's good. You FOILed it out just fine. You can't... And again, you can't put yourself through all that. This is, I have to show you this one. This is A plus B equals A squared plus 2AB plus B squared. This is your 2AB. AB. Once you start putting yourself through stuff like that, it's for sure.
Okay.
The combination of having done that there and having done it again there, and it's blowing up in complexity.
Yeah.
And then, but it's not wrong though.
Right.
I don't see any. Can't quite. I mean, 18 squared seems that's around there. The negative on that one seems okay.
I haven't even crunched numbers just because the notation doesn't work out here.
Yeah, the units got lost a little bit. But that's just not the way you're meant to do the physics. Don't do that. There should never be, when you write numbers down, don't write units down. Only when you're labeling it.
Huh?
Up front, like up front, I would have wanted to write each of the variables I had, which this is delta x, right? So I would want to say delta x equals 62.9 meters. And if it wasn't meters, I wouldn't even write it down any other way. Just go right into SI. And then here T equals. And then here V naught equals.
Okay.
And then the units, I'm never going to write them down again until the very last step.
Oh,
I'm not going to
throw a hissy fit like that.
Does he every step he writes it like that? Nobody on earth does that, but certain physics teachers. I mean, you would never do that in practice because it's so confusing.
He's told us this story twice already.
What did he say?
He was he was studying for his PhD, and I guess he had this huge report that he thought was really good, and he brought it to his supervisor, and they're like, the units are wrong. And he was so embarrassed because it was like a first level freshman mistake that he made, and like 2 weeks of work went down to shit. Like,
even the units are wrong. It's not the same thing.
So, yeah, he has this
as writing them down on every single step.
And on the test, he's already told us that if our units aren't right,
In the answer.
No, even in the answer.
It's in the answer. In the question.
No.
In the answer.
Obviously,
but look at what I've done here. Was there any cause for me to write units?
On our quiz. I don't know about the test because I don't know how he grades the test. But in the quiz, he wanted us to have the units right the whole way through.
Yeah, but you still don't have to do that because you could just solve it without ever writing the numbers down until the last step.
I wish I could do that.
Yeah, I think.
Well, it looks like I'm going to have to not get in the habit of that, or else I'm going to get a bad grade.
I don't think he would mark you off for that. I think he'd be impressed.
On the quiz, at least. I don't know about the test.
Like, I'll show it to you. This is what I would do. This. I was on the test, and this bastard didn't go for this. He just doesn't expect it because he doesn't think that you have the math skill, but I think you do. Not every student in this class has taken as much math as you. Most of them are maybe up to Calc 2 and they got C's. Yeah. Or they worked to earn C's, in fact. It's a different thing than getting a C. Whatever grades you get, it's the grade you really work for. It's a different thing. So I would write up front, I would say A equals negative 5.7. I would absolutely write the units down here because I'm concerned that I mismatch or that they're not in the right. They could be centimeters per second or some wrong system. For your level, I would not put it on the page unless it was meters per second. So I would convert it before it goes on the page.
Okay.
Just to keep it clean. And I also have t equals 4 seconds.
How are you going to just keep... I mean... You're trying to declutter things, but once you actually end up cluttering things more by having a second piece of scratch paper to do the conversions? Or how are you going to do the conversions without writing them out?
You can do it on the page if you want.
Okay.
But at least do it like over here or something.
Okay. Alright.
This it's not like this stuff is core to the whole question. Skid marks of a length. That's not a position and a position. That's a length, so that's a delta x. So delta x is going to be 62.9 meters. Okay. And then I want to draw some kind of a little picture. Not much picture to this.
Mm-hmm.
It's at best it's a number line. Just start, stop, and then there's a V naught here. I don't know what it is, and there's a VF here. I don't know what it is. That makes that clear. I'm not going to make the confusion. And then I start to think about equations. You thought delta V equals AT, right?
I actually thought about the BF squared.
Oh, you did it right there. It was the first. Must have been one of your first thoughts.
Right.
That was good. I can get a number from that. We'll go ahead and work out the number right here if you want. And if you want, if you feel he'll complain, you're probably right. Then go ahead and write negative 5.7 meters per second squared times 4 seconds. As that cancels, that produces meters per second. Equals, and you get a number there.
Mm-hmm.
And again, you write it as meters per second. I agree. Don't write a number down and then what is it? Because you're almost guaranteed to make a mistake. But notice I only wrote it down once. Just to get the delta V. Now I have that. Delta V now is one of the 4 things I have.
Mm-hmm.
Okay, but that did not get me to the answer. So I go for another kinematic equation, which is the delta x one. Delta x equals...
Oh, sorry. Oh.
V naught t plus 1/2 AT squared. Okay, now look at that, and I realize that I have that one. I want that one real bad. I like that. I have that one. I have that one. I have that one. And therefore, I'm in good shape. But I'm not going to just start putting numbers in because I can do this algebra. This is algebra you should be pretty good with.
Mm-hmm.
How do I solve? I want V naught, right? So I'll just go ahead and solve it for V naught.
Mm-hmm.
That would take like a couple of steps. You would multiply the t across, and you'd multiply the 2 across. You'd
get the negative of this by t.
You'd subtract that and you'd divide it by t. So you'd get 2 delta x minus AT squared divided by 2t. Okay? You take a couple of steps to do that. Or I could have even made a mistake there just trying to show off. But so you do a couple of steps with that. Every day 4 or 5 steps, whatever it takes. No numbers. There's no call for that. I promise you physicists don't do it that way. They just show that in class because they've seen so many students who are so plug and chug ready, just want to plug numbers in. They don't want to believe it's real until there's numbers. Because you do get a feel for it, like it's going to the right, it's going to the left, but you lose all the meaning. This still has meaning.
Gotcha. Yeah.
Now, I could plug in everything, and you write all the units down as you do if you like, to get V naught,
Okay.
and then I could add delta V to it, and I get VF. Or, if you wanted to go crazy, you could say, oh, VF is V naught plus delta T, so you would add AT in there, blah, blah, blah.
Okay.
However you like.
I see what you're saying. I actually started doing that a little bit myself, too.
Definitely the more beautiful solution is to say that V naught, or, let's see how this sort of comes out. Or, one more step. V naught equals 2, nope,
We got a call. Sorry.
delta X over T.
Hello? Hey. What was that? Very nice. Let me text you about that later. I'm in the middle of something right now. Okay. Alright. Bye.
There.
So yeah, you're doing all the
So you do it all algebraically. There's less numbers to type in now. Then, okay, write all the units out if you like.
Yeah, that makes
That
sense.
is
I understand
worthwhile
what you're saying.
to cancel.
That illustrates your point well. Thank you.
There.
Because I was thinking that something totally different.
Yes, a picture is worth 1,000 words, they say.
Okay.
Still easier to make a picture with paper than it is with this, but I don't have much experience with it, so.
Yeah, there you go. I used paper.
Yeah, I think for some of these things it's gonna ultimately be worth it.
So 4. I'm trying to figure out why I'm not getting the right answers on that.
So I just sometimes when I tutor this class, I like to say, I know I can't. What are you doing? Stupid Microsoft. Come on, let me have it. There we go. If it doesn't show you what you want to sketch on first, it just won't let you sketch on it. Come on.
Problem over there.
It is, yeah.
There we go.
It's because I'm overtaxing it by compressing 4K. But this system, which is an older CPU, handles it fine on Linux. And with no effect, no visible side effect. Just takes one processor, 100%. I have the other 3. For some reason, this guy, you take one processor, 100%, it's dog down. The other 3 can't go.
That's not good.
Unimpressive. So, but if I take that same blind approach, I want to label things.
Mm-hmm.
A, the constant acceleration over time reaches. There's no directionality in any of this, but I'm going to take the A and I'm going to take the VF. Okay. If its initial velocity, what is its displacement? You got that one?
Mm-hmm. I forgot. I mean, the answer, all it's asking in the second, in the part that I missed, is just the variation of the first one, which I use all the computations from A and just change the B number,
Yeah.
which from negative to positive, and I'm not understanding why I'm not getting the right answer.
Huh. It says it has the wrong sign.
Yeah, which doesn't make any sense at all either.
Well, this is a different question. You can't necessarily carry the computation through because it's a different initial velocity. 5.3 versus negative 5.3.
There'd only be a sign difference, and I counted for the sign difference. So instead of positive 7490, it'd be negative 7490. So I just said Okay.
So that's A up to there. This is B? Or how many went from A to C?
That's A even up to here. That's A right there.
Oh.
And B is the same answer.
Oh, okay. This is a total distance versus displacement. How are you accounting for that? The change in position is the displacement. The total distance traveled is the mileage. Mileage is determined by counting between stops. That's probably, it didn't matter in the first one. It was the same.
That's why
and then when you turn around and you go backwards, your distance keeps increasing, but your displacement decreases.
It would be the same, actually, instead of...
Well, see, anywhere where you're solving for v equals 0. You need to know when v equals 0. Because if we think of it in terms of a number line, if I go from here, and I travel down to here, but then I stop and I come back this way to here, then this is a v equals 0 here. That's a turnaround. So I need to know that point so that I can measure the two distances separately. And it becomes a two-phase problem.
It's a constant acceleration.
In terms of math, you're actually integrating the absolute value of velocity dt. When we're doing absolute value integrals, you have to split it and make it a multi-part integral. It becomes the same thing here.
No, I don't remember that at all.
This is they kind of touch on this.
Yeah, you can't integrate that because it's...
You can't integrate an absolute value. You can't integrate something with a sharp corner. You can't differentiate with a sharp corner.
You still have to split it up.
You have to split it up. And you have to split it because it's an absolute value. The sign flip, you have to split it at the sign flip. So distance is a special integral, which all means you have to split at that v equals 0 point. So you have to solve for all the v equals 0s, which in terms of Calc 1, that was the setting the derivative equal to 0 thing. Same thing. V equals 0 is delta x, delta t equals 0.
Okay, yeah.
So you've seen all this. You know all this calculus. So,
instead of 10.6,
let's go
you do the 10.6.
Let's go back and... So we have to include that bit of logic. That's why it's not going right.
I didn't think about this for a second. You said you need to figure out when velocity is 0 and split it up based on that point, right?
Yeah.
One's positive and one's negative.
Another great way to look at these is to do velocity, acceleration, time graphs. Acceleration is constant. I'm not going to bother to graph it, but it's positive. Always positive. The velocity, for case C specifically, if I do velocity versus time, it starts out as negative. But because the acceleration is positive and constant, and we know that v equals v naught plus at, well, here's v naught, negative. Graph it as a linear. This is t over here, of course. That is a y equals mx plus b graph. There's the b, there's the mx. So therefore that graph looks like that. Now I didn't particularly pay attention to the slope, but the slope is whatever the acceleration is, so it's steeper, flatter. But the point is, it's eventually going to cause it to cross.
Oh, you can solve for 0 that way. That's how you... Okay.
That's my v equals 0. But I need this because I understand now it's only going to happen once. There's no cause for it to turn back around. It's never going to in kinematics. But, well, they will in this class, so they'll give you accelerations, which are functions. So you have your acceleration as a function of time is a constant.
Mm-hmm.
But it could be a constant times t. Or t squared. Or whatever. And all these things can still work.
196 is when they give you another.
They'll throw a little bit of this into this class, but it's not real important. I like the top thing.
Gotcha.
Kinematics is the assumption A is a function of t equals c. Some constant, typically gravity, but actually in the beginning of 196 they hit this all over again. What I just did this morning. Different constant, but so I have that graph.
Right here, I think. Number 2, you were going over this before. I figured out what the slope test was.
Yeah, so the graph is great. You just don't necessarily want to do an area-based integral or really do an integral at all because you already have the equations all solved. The purpose of the graph and understanding the integral thing is to get where all this is coming from. So it has meaning as opposed to if you just follow the equations, it's meaningless.
Right.
So we solve for that point and we know it's going to be there. But then when we integrate this, so we want to think about x, well, the initial position doesn't really say. So we'll have to assume the initial position is 0.
You can do that. Oh, well, it's arbitrarily you can still say it's 0.
In fact, in all problems you have to do that because there's really all different orientations. So everything in the room is facing a different way. So that's normal. So I'll just assume it's 0. And they're interested in displacement and distance traveled. But its initial velocity is negative. That means the position is going to get to be less over time. It's going down.
Mm-hmm.
But with less and less velocity. And it's an integral, so this is a parabola. Integral of a line is, this is a t, so integral of t is t squared. 1/2 t squared.
Did not know that.
That's just the fundamental.
Line is a parabola.
Yeah. Calculus was fairly well invented to explain that.
Oh, yeah, I guess that makes sense. So I think it's tangent. And one opposite way is the derivative.
So, now that I want to understand the total distance traveled, well, I went from here down to here, and then I went from here up to here. If I want to know the total displacement, that's this here.
Right.
Different thing.
Okay. I didn't realize the 2-stage part of this. That's why I wasn't getting it.
They do that on purpose, so that the second stage wasn't different on the first one because you were going in the forward direction to begin with.
Right. Never flip side.
So the parabola ends up looking like that.
Yeah. Alright.
Okay, now you know how to do that.
Well, I never actually did the computations for 5 and 6, but at least I don't have to see. I had them figured out.
Couldn't render that image. I don't know why you couldn't render that. Ran out of resources, I suppose. It's crap. Okay, I think it saved it though. Alright. Sometimes the ones with lots of little questions can actually be good because that means they're leading you along.
Right, yeah.
That could be nice.
So this is what I did for 5, and you're gonna like what I did because I set it all up exactly how you were telling me to.
A and B. Oh, they're 2 devices or 2 objects.
2 cars, yeah.
A. The notation is a little different. It should be XA naught or something. Normally we would. Well, yeah, it's fine, whatever. Like piece of A, BF equals V naught plus AT. So this is actually acceleration for A. And then which A is that? This is either particle A or particle B you're talking about.
It's sure. Oh,
Maybe.
this was just general, and then I just assumed that since we're trying to figure out, since their final velocities are the same, I can set this side equal, the right side equal to the right side, and then plug in the t's there, and that. So this would be A would be one side, B would be the other
At
side.
what time do they have equal speeds? Which is not equal velocity. Equal speeds means equal magnitude of velocity. They may in fact have equal speeds in the opposite direction.
That's true.
But you can still do it by deriving the different velocities. Notice it just says one toy car and another toy car. Although the letters are okay, I would have labeled them 1 and 2.
Okay.
And the reason would be so that I can say at time 0, so I can make some sort of a table, which is what you did here, time 0, and then at some other time. But at time 0, initial position, that was for A, so I would say x1 0, x1 naught. And then I would have
sub-0 or 1, 0.
x2 naught. They're just car 1 and car 2.
But is the 0 a subscript of 1 and 2, or is it just...
They're both subs of x.
Okay, so they're on the same level.
Yeah.
Okay, alright.
So the concept is that x sub 1 is the first car.
Mm-hmm.
X sub 1 naught is its initial.
Gotcha.
Or because I'm only saying x, it's not a vector there. Anyway, the result of that is I can have V and A, and I can stick in the visual that I'm used to, as opposed to letting the car be the dominant thing. I want X, V, and A to be the dominant thing, because these are these new concepts that you're trying to get used to. They're more important than which car it is. But you get all the same stuff. So it has position to the right, and it would help to draw a picture, because it's a little hard to... So car 1 is over here on the right somewhere, and moving to the left, and accelerating to the right.
Oh gosh, yeah.
And when the velocity and acceleration are in opposite directions, you're going to get confused. Not necessarily have to split it up, but there's a tendency to think that the two should always be the same way. And they're just not. And then the second car has initial position 9, a little further over here to the left, and initial velocity to the right, and acceleration is always 0. So it's just going to cruise to the right. This guy's going to go to the left. But this guy's initial velocity is on the order of 5. I'll just say 5. And this one's initial velocity,
-3.
yeah, is about 3 to the left. Which I should write -3. But no amount of acceleration to the right is going to turn that 3 into a 5.
Mm-hmm.
If this one had started at a 2, then we'd have that first solution. But we don't.
What? It started at 2. What?
Man, let's see if we can draw a graph. If I graph my two velocities, I'll graph velocity 2 first, which is always 5. So there's velocity 2.
Mm-hmm.
Velocity 1 starts out down at -3, and it increases in a constant way. So they're definitely going to cross. But they're only going to cross like right there.
That's not position now. How do you know that dude actually crossed there?
Well, it's not position. No, it's velocity. This is just to increase its... In kinematics, if constant acceleration, the velocity is always a line. It might be a horizontal line, it might be a tilted line. That's all it's ever going to be.
But they're not going to cross that.
Yeah. Oh, I don't know where they'll cross.
Okay.
But it'll be somewhere over here.
Gotcha.
It'll be at some t, which I think was the answer. That's the answer to A.
Okay.
However, if... Maybe this is going a little too far. But, you know what I mean? If V2 had been a negative number, and not too negative... Oh, wait a minute. No, if V2 had been lesser, so let's say V2 was 1, then they would have been going the same speed at 2 points. Same speed, not same velocity, but they just asked for speed.
I don't get the second line. What's that?
That's negative 1.
Okay.
Because speed is the situation where the absolute value of V1 equals the absolute value of V2. And that's true there. Negative 1, positive 1, it doesn't make any difference.
I see. Okay.
This is technically what they asked for, but it didn't happen here. Usually they make it happen in the second part.
And you're saying if they ask for something that's below that.
If they ask for speed, then it's magnitude that matters, not the direction. So you can't just set it equal. You have to have this analysis.
Gotcha.
So at any rate, for this one, it's real straightforward. You just apply the kinematic for velocity, and you'll get the answer. Which,
so you don't have to split it up.
Yeah. Which is pretty close to what you did. Do they have equal speeds? The way I would go about that, though, is that V equals V naught plus AT. I would just set them equal. So it would just be V2 naught, which doesn't change, because car 2 doesn't accelerate, equals V1 naught plus A1 times the time, and you'd solve for T. So T would equal V2 naught minus V1 naught over A1.
So that was pretty much what I had there, but
Yeah.
Didn't really think about it in depth like I needed to apparently.
It's the drawing the picture is the hard part. The picture that really makes sense.
Yeah.
You can see the picture but not draw it, that's okay.
What are the speeds at that time? That one's easy, just plug in.
Well, you have the T, you can plug it into either equation.
Yeah.
But it has to be... What are their speeds? Wait a minute. If you plug anything in there, then it needs some more considering. What must their speeds be when their speeds are equal, when the speed of one doesn't change?
Okay, well, I guess it would be the 5.6. So I'm gonna say. Oh my gosh. It should, if you plug it in though, it should come out to that, shouldn't it?
Yeah, this is the Sunday driver phenomenon. You got a guy that drives just at one steady speed, and you speed up, you slow down, you speed up, you slow down. Your speeds can be the same at various points. He doesn't ever change.
Sunday driver.
But it helps, I think, when you're taking this class to look at some of those things that way while you're driving along, because you're in this world when you're driving.
Yeah.
To think about it, I guess. Too distracted, but.
Oh, wow.
Do the cars pass each other?
What's the detail on this? Because I noticed he extended it. So I'm just wondering if I have Wednesday get help on this too.
So they pass each other is when their positions are the same. But I think the way you were approaching that one there was pretty good.
Sweet.
Just as long as you use the variable labelings the way I showed you.
Yeah.
And be clear when you work out the different parts, which car are you working on? Or which phase? Because those are the two things, well, three things they're going to do here. They're going to be multiple particles. No, they're not really cars or motorcycles or any of that. They're multiple particles moving in one dimension. They're going to be multi-phase problems, where you have to go through a phase that starts the second phase. And then they're going to be multi-dimensional problems, where something happens in X and something happens in Y, and it's always time that binds them together. X and Y are not related in any other way except time. So you have to pick one, find the time of the event. There's an event, which then connects to the other.
Okay.
Just the three big ways, I think.
That's good to know. I've read that, what you're talking about particles. Like, really only dealing with particles here.
Yeah.
And constant acceleration.
And it helps for some people
distance.
to humanize it and talk about cars and stuff. But you can't draw that picture.
Alright, so 6. I have.
So downward. Yeah. This is about positive, negative. Have you ever thrown a ball down?
Mm-hmm.
Yeah, probably. What do you mean? Yeah. You've thrown a rock at the ground. Like kicking a ball?
Dribble a basketball.
Oh, you're right. Okay. I'm not a basketball player. Most games involve throwing the ball up.
Right.
So it'll go somewhere. No, you're right.
Yeah, that's all you're doing in basketball, is throwing it down until the last.
Yeah, and then you get to throw it up in the air. I never thought about that. But you probably don't realize that it's going even faster when it hits the ground than it is when you throw it.
No.
I don't think most people notice that. If you want to make it...
stop it after it bounces, it's a lot harder to do it closer to the ground it is. It's a lot faster.
I have seen people do that. They get down, they dribble real close to the ground because they actually dribble down, sort of.
Uh-huh.
And it gets faster and faster because the energy is compressing in it.
Yeah.
Yeah.
I play a lot of basketball.
I see. So if the ball is going down, what is that? Then that's the magnitude. Notice they said speed there. They can be pretty careful with the wording on these things.
Uh-huh.
So they went right on there and gave you a speed. So that's not the velocity. What's the velocity?
With direction?
Yeah.
The speed of direction, but...
Velocity is speed with direction.
So I guess it would be
it's down.
negative 7.05.
So maybe not it's negative. That's where most people go wrong on this.
I fell for it.
There's an X naught.
I did 7.05.
X naught is that? What's the final X?
What do you mean? Oh.
It's the ground.
6 minus X naught?
Minus what? No, what is it when it hits the ground? The ground could be anything. But what's height? Height above what?
The X.
What is the height above?
X-axis.
When you throw the ball in basketball, you throw it from your height, maybe 2 or 3 feet or whatever, at the ground. The 3 feet was above the ground, so what's the height when it hits the ground?
0.
Yeah. So x is 0.
That's what you're saying.
That's important because it's another one of those variables off that list. I have an x naught and an x, which really means it's a delta x situation. But if you try it that way, you're gonna get the delta x backwards because delta x. What's the value of delta x?
Xf minus x naught.
Yeah, but how much did it move? Did it move up or down?
Down.
Down. So delta x would have to be negative 29.6.
Yeah, I did that.
Which is fine, in which case now I don't have to do either of those. And this is both. These are both just, they gave them both G negative.
This is how I set it up, and those should both be negative right at the top.
Yeah, it'll all be fine. Yeah. I used to do that when I was learning this, and the signs would be wrong in the end, so I would just flip them until it worked.
Until it made sense, or yeah.
Well, until it worked, and I would go back and I would say, which way should I have gone?
Alright. Okay.
After that, it's going to produce a quadratic. That's not a big deal. Deal with that.
Is there another way to do it so you don't deal with the quadratic? I remember our teacher showed us 2 ways to do it. One that didn't deal with that.
Well, with the 3 equations you got, you don't have VF. You have V naught. You have A. You have delta X. Yeah, you can get VF. Yeah, so you could use that third equation. You could say VF squared. In fact, I think in general, if you do the big kinematic equation, x equals x naught plus all that, or the delta x one, and you get a quadratic out of it, that means you're solving for t. And then that's what this one is a shortcut for, typically. So you might look back and see if you could do it. I wouldn't, like if I was taking a test or a quiz, I'd just go for it. Just do the quadratic. But,
you could do both to check your answer.
Yeah. Out of here, again, if I go through the list of what I have and what I don't have, I have V naught. It's negative, and when I square it, that won't matter. I have A, because that's G, negative G. I have delta X, which is also negative, so this comes out positive. And VF squared has to be positive as well, so that's going to give me VF. But that wasn't what you wanted. But once you have VF, you can do VF equals V naught plus AT.
The small kinematic. Is that how you refer to it, small and big kinematics?
Yeah, well, this is the big one. Nobody likes the big one because it's got the 2 t's in there. One of them is squared.
Yeah.
That's not very
And an x variable.
Yeah, a lot of stuff.
2 technically.
It's got a lot going on.
Alright.
But this required that you pull out 2 equations and go through 2 steps, where if you had put it in the other equation, everything would have been there. It's just there would have been 2 t's, and it would have been a quadratic, and you solve that instead.
Cool. Alright.
This is almost like I complete the square, basically. It's all for you. You just have to do a square root. Okay.
Well, I'm trying to figure out. That's all I have for.
Okay.
Problems that I tried.
Well, that's a lot to be went over. So once you go off and try those.
Yeah.
Try those methods that I talked about.
I'm glad he extended his deadline because otherwise I'd be trying to submit it by myself without having any. Like, I'm sure I can get these, but like, there's gonna be little mistakes that I'm gonna make. I'd rather have all the ones I can get. So Wednesday I'll talk to you and clean that up.
So I think the things we came up with was to write all the variables down with the units and the sign, and be very careful about each of those things. Correctly identifying them because of the units, and then correctly identifying whether they're positive or negative. Looking for things like speed, words like speed and magnitude, which means I didn't tell you the sign.
Mm.
And then
that's the big difference. At this stage?
If you see either of those words, that is a red flag. That did not give you the sign.
Okay, that's all it means.
They don't always give it away.
I was thinking it's going to be more involved than that.
If they ask for the answer in terms of speed or magnitude, that means they don't want the sign, which means positive.
Okay.
Then writing down the equations that are connected to those, trying to solve with variables, to what extent you feel is reasonable. I don't think there's any equations in this class that you can't readily solve with the algebra. What was the other key thing? Oh, confident. Don't let your confidence break. Because once that happens, you just can't make decisions anymore.
Interesting. Okay. I mean, that did kind of happen here. Although, I figured it was one of those things that I didn't know what I was... There's one little thing I didn't know what I was doing, and it's going to screw everything else up. But I guess it's kind of the point.
Yeah, that's gonna happen. Yeah, that's just gonna happen.